Car catching the truck. This is a great problem for taking those kinematics equations that I'm sure you've worked with already and using them in a new, more interpretive way. Let's start by establishing what we know about the motion of the car and the truck individually, and then see how we can use that information to figure out when and where the car catches the truck. Now, we're told the car has an initial speed of 0. It's sitting still when our problem begins, but the car does have an acceleration, 3.2 meters per second squared, we're told. So think back to the equations we have for determining distance traveled as a function of time. There's that great kinematics expression, distance traveled equals v initial times t plus 1/2 a t squared. And for the car, that means with an initial velocity of 0 that this entire term goes to 0, and 1/2 times 3.2 gives us 1.6 t squared. We can do the same sort of thing for the truck. The truck does have a non-zero initial speed. It's traveling at 20 meters per second, but we're told that's a constant velocity. The acceleration of the truck is 0. And so with this same equation, VIT plus 1/2 AT squared, we get an expression for the distance traveled by the truck of 20 times t. Now, we need to figure out what it means in terms of these equations for the car to catch the truck. And what it means is that the distance traveled by the car is equal to the distance traveled by the truck. Now, we know that's true at time 0, but that doesn't really help us out. There's going to be another time when the distance traveled by the car and the truck are the same. If you imagine the situation, initially the truck goes ahead of the car because it's already moving faster, but as the car speeds up, it eventually gets faster than the truck and catches it. So let's make these two expressions, 1.6 times t squared, and 20 times t equal to one another. 1.6 t squared is the distance traveled by the car, and 20t is the distance traveled by the truck. And when those are equal, then the car has caught the truck. And we do a little bit of algebra here. We find that time is 12.5 seconds. Now, that doesn't quite yet answer our question. We need to figure out how fast the car is going when that happens. Well, we have another great equation that says velocity is equal to v initial plus at, and we have everything we need to complete this equation. The initial speed of the car is 0. Its acceleration is 3.2. And the time is 12.5. And so we find that the car is traveling 40 meters per second when it catches the truck. If we need to, we can go back to these distance equations and find out where the car passes the truck as well. Simply substitute our time of 12.5 seconds into either of these equations. In fact, if you enter it into both equations, you should get the same answer, which tells us the car and the truck have traveled the same distance and the car has caught the truck.